Hi grade 11s, I hope you had, let me just put this on. Yes, I hope you had an awesome weekend and you got a lot of rest. Okay, today we are doing lesson 5, negative angles. Okay, so we've worked with negative angles before with our reduction formulas. So we have an idea what it is, this is just to better explain them and to show you how to apply them. Okay, so here we can see two triangles. First of all, we can see that this triangle is an exact mirror image of that one, or the other way around. It depends how you see it. Okay, so that means that R will be the same, because R is always the same, and R is always positive, so R is 5. And they will also have exactly the same coordinates. X or Y will just change into negative depending in which quadrant it falls. So in this case, the Y coordinates will change to -3 because over here under the X line, Y is negative, but X stays positive. Okay. So you can see that this is exactly that angle, just the negative one. Okay, so when we work with positive angles, guys, we start here and we go in a clockwise direction around the Cartesian plane. But when we work with negative angles, we will start here as well, but we are going to work the other way around. So we're going to work in a anti-clockwise direction. No, this is clockwise, this is anti-clockwise. The point is when we go up and around, we are positive, we have positive angles, and when we go around like that, we have a negative angle. So here you can see then that this is exactly that one, just the negative angle, because we worked that way. Okay. So remember, when we work in quadrant 4, this one falls in the fourth quadrant. It is the same as 360 degrees minus theta. Okay, and remember here that cos is positive in quadrant 4 and sine and tan is negative. Okay. So guys, when we apply this work and when we work with reduction formulas, please, it's very important to know all the little things from the previous lessons, that when we work here in this quadrant, we work with 180 degrees minus theta and also 90 degrees plus theta. In this quadrant, we work with 180 degrees plus theta, and here we work with 360 minus theta. And in this quadrant, the first one, we work with 90 minus theta. Guys, you have to know that. Remember as well, sine of 90 plus or minus theta changes to cos of that angle, depending on the quadrant, and the other way around as well. Okay? And for all the others, sine, cosine, or cosine, tan, and sine will stay the same when we work with 180 or 360 degrees. Okay, it's just when we work with the 90 degrees that they change. Sine changes to cosine, cos changes to sine. Okay. So very important in this work is this rule is to change the negative angle to the positive angle first. Okay, because they're always going to ask you an angle and they're going to ask you to write it as a positive acute angle. Okay, then you have to change the sign first, and then you change the angle to an acute angle. Okay, so let's do an example. Tan of negative 150 degrees. First of all, remember that when we work with negative angles, we work that way. Okay, so let's take the negative and put it in front. Okay, so then we are going to write that as its reduction formula, or as a reduction formula. So we're going to change it to 180 degrees minus 30, because that is the same as that. Why do I do that, guys? Because tan of 150 degrees lies in the second quadrant. 150 degrees lies here. And in the second quadrant, we work with 180 minus 30, and the 30, we want that because we want an acute angle. Now remember what our rule says, that tan of 180 degrees minus or plus any angle will be the same as tan of that angle. Only thing you have to take note of is the positive or negative sign. So then you have to go and look in which quadrant it falls. Okay. Now, 150 degrees, guys, falls in the second quadrant. In the second quadrant, tan is negative. That's why I have a negative tan in the brackets. And then I just don't forget about the negative over there. And a negative times negative equals positive. So there I have my positive acute angle. Okay, let's do another example. Cos of theta minus 90 degrees, guys. Theta minus 90 degrees. That is not something that we want to work with. We want to work with this. We are used to 90 minus or plus theta, not the other way around. Now, in order to change that, to switch them, we take out the minus or a minus. We put them in brackets and we switch them. So now we switch the 90 and the theta so that it says 90 degrees minus theta, and we just put a negative sign in front of that. Okay? So here we can see, guys, that we are working with a negative angle. So we are working with negative 90 minus theta. And again, when we work with negative angles, we go anti-clockwise. So if negative minus theta falls in this quadrant, and now we work with negative 90 minus theta, it will be the negative of that angle which will fall into this quadrant. Okay, because it's a negative angle. Okay, so in the fourth quadrant, cos is positive. So it changes to positive cos 90 minus theta. And remember the rule, cos 90 degrees minus any angle is the same as sine of that angle. Okay, and now we have a positive angle, and that falls in the first quadrant, and in the first quadrant sine is positive. All of them are positive in that one. Okay, how you can also see this if you get confused with the signs over here, with the negative changing to a positive and y, etc., is that if you look at 90 degrees minus theta, oh my word, now I can't remember the other way I saw it. Okay, guys, I can't remember it now. But anyway, just know always that a negative angle will fall of this. Negative angle of this will fall in the fourth quadrant because we worked that way around. Okay, so that is why it changed to a positive, because that will be in that quadrant, cos is positive. Okay, now here's your homework. Exercise 4 on page 148. Number 1, please do B, E, H, and K. Number 2, only C. And number 3, A and D. Good luck, guys, and please send your work again as usual and enjoy the day.